In this video we will see a reslicing operation for double volumes. What reslicing operation allows you when you use double volumes is it gives you ability to do volume calculations. So for example, you have two volumes, say you name it as A and B, then uh, then you can do A plus B, A minus B, mod of A minus B, and so on, or max of A plus B, max of A comma B, and so on. So what I'm loading here are two volumes from bone compression dataset. This one here is an uncompressed bone data, and this one here is with full loading of the bone, so basically fully compressed. So these are the two volumes here. So this is one volume here, and this is the other one. So let's go into high res mode by pressing F2. And let us tweak the transfer functions. So from here to here, and for the other one as well. So these are the two volumes now. So this one is the uncompressed one, and this one is the compressed one. So what we can do now is apply reslicing option. Let me turn this thing on. So apply reslicing option and get A minus B or A plus B and so on. So apply reslicing, so space bar and then reslice. But instead of using reslice, you should use reslice normal, because if I use reslice, I'll just give cancel, then the volume that is stored will be in this orientation, and what we would like is to have that in the standard orientation. So instead of using reslice, we will use reslice normal. Reslice normal. And then whether we want tight fit, yes, we would like to have a tight fit without any clearance. Let us save it as T or A minus B. We would like to save value. So when we select the value option, it will take the value, the voxel value at a point, and then take its whatever calculation we specify next. So in this case, it will take voxel value from volume 1 and voxel value from volume 2, and then perform the calculation. If we do opacity, then it will take the opacity of the voxel based on the transfer function for volume 1 and similarly for volume 2, and then perform the calculation. So let's use value, and then we have many options here, A minus B, mod of A minus B, and so on. So let's choose this one here and OK. So what will happen here is, if the value resultant value of A minus B is less than 0, then it is saturated to 0. So anything less than 0 is set to 0, and anything greater than 0 is taken at that value. With mod of A minus B or absolute of A minus B, if the value is less than 0, then it is basically set to the positive value. So minus 5 or minus 10 will be set to plus 10. So basically taking the absolute value. So right now we have saved it as A minus B. So this is saved. So let's have a look. Let's load another version of another instance of Drishti and drag and drop A minus B, the volume that we created. So this is the volume that we created, A minus B. So as you can see, the top bit is is removed here, and similarly the bottom bit. So a minus b. So that's how you would do a minus b. Save the project. No. So that's how you would perform all the other calculations, a minus b, a plus b, a star b, a divided by b, and so on, using value as well as the opacity. So you have both the options, and use reslice normal instead of reslice, because let me also show you now what happens when we use reslice normal. So I've got this one here. Now reslice tight fit. We'll apply the same operations that we did for the previous one. So let's call it resliced a minus b. We'll use value again, and then again same a minus b. Done. Now observe that all these calculations are being performed on the GPU. Okay, now let's drag and drop our a minus b. So this is what you get when you do the reslice. Because my volume was in this orientation, my resulting volume has now is now in this orientation, the orientation as we see here on the screen. So that's why I recommend the users to use reslice normal for most of the cases.